Morning friends, last period we see the failure of wave theory of light and dual nature of light or dual nature of radiation. मागच्या पिरियडला आपण वेव्ह थेरीचे फेल्युअर बघितले आणि आपण त्या ठिकाणी लाईटचं ड्युएल नेचर बघितलं, रेडिएशनचं ड्युएल नेचर बघितलं. ह्या पिरियडमध्ये आपल्याला बघायचं आहे आइन्स्टाईन्स पोस्ट्युलेट ऑफ क्वांटायझेशन ऑफ एनर्जी and photoelectric equation. Here Einstein explained all characteristics features of the photoelectric effect by using Planck's quantum theory. जे फोटो इलेक्ट्रिक इफेक्टचे कॅरेक्टरिस्टिक्स फीचर्स आहेत हे एक्सप्लेन केले आइन्स्टाईननं, परंतु कशाचा यूज घेऊन? प्लँक्स क्वांटम थेअरी. आता अकॉर्डिंग टू अँड आइन्स्टाईन एक्सटेंडेड प्लँक्स क्वांटम थेअरी टू एक्सप्लेन द फीचर्स ऑफ द फोटो इलेक्ट्रिक इफेक्ट. आता अकॉर्डिंग टू प्लँक्स हायपोथेसिस और अकॉर्डिंग टू आइन्स्टाईन light has the particle nature. He considered light as a particle nature, and each particle of the radiation consisting of the radiation consists of photons. According to Einstein, light propagated in the form of photons, and each photon has discrete energy packets. Each photon has the discrete energy packets having energy in the form of energy bundles or discrete packets or energy bundles. And these energy bundles or discrete packets are called as quanta or photon. The light is propagated in the form of photons, and each photon having energy in the form of discrete packets or energy bundles. And these energy bundles or energy packets are called as photons. These energy packets travels with the velocity equal to the velocity of light, that is 3 into 10 to the power 8 meter per second. If nu is the frequency of each photon, if nu is the frequency of radiation, frequency of light, then energy of each photon is E is equal to h nu, where h is the Planck's constant and nu is the frequency of each photon, and this frequency can be given by nu is equal to c upon lambda, where lambda is the wavelength and c is the velocity of light. This is the quantization of energy. That means light consists of discrete energy bundles. Light is propagated in the form of discrete energy bundles or energy packets, and each energy packets are known as energy bundles are known as photons, and this energy will be given or emitted in the form of integral multiple of h nu, that is E is equal to n h nu, and this is known as Einstein's equation, or this is known as quantization of energy. आता from this Planck's quantum theory, Einstein explains all the observations, all the characteristics of the photoelectric effect which we have seen from the experiments performed by the Einstein. आता we have to see the first observation or the first characteristics of the photoelectric effect. Here we know that light is propagated in the form of energy bundles or energy packet, each photon having energy equal to h nu. Means when light is incident on the metal surface, each photon gives energy equal to h nu. Each photon gives energy equal to h nu टू ईच इलेक्ट्रॉन. जे इलेक्ट्रॉन फोटॉनच्या कॉन्टॅक्ट मध्ये येतात त्या प्रत्येक इलेक्ट्रॉनला एनर्जी किती मिळते, फोटॉन लॉसेस एनर्जी and electron gains energy equal to h nu. But when the frequency of the incident radiation has some characteristic frequency for which electrons emit from the metal surface, and that characteristic frequency is known as threshold frequency, or it is known as nu naught or work function phi naught. आता when frequency of the incident radiation is smaller than this threshold frequency, then electrons are not emitted, not ejected from the metal surface. But when the frequency of incident radiation is greater than or equal to, nu is greater than or equal to the threshold frequency, then only the electrons are emitted from the metal surface. This is the first observation or the first characteristic of the photoelectric effect. Means for the ejection of electron, the incident radiation has some characteristic minimum frequency, and that frequency we know the threshold frequency. And for ejection of electron, to knock out the electron from the metal surface, the frequency of the incident radiation must be greater than or equal to the threshold frequency, whatever may be the intensity of light. Whatever may be the intensity of light, this is the first characteristic. Second characteristic, when light radiation in the form of photons incident on the metal surface, या metal surface वर आपण जेव्हा light incident करतो in the form of photons, there is the photon gives energy to the metal surface, photon gives energy to the electrons, and there is the exchange of energy between photons and electrons, and hence this exchange will be takes place in a very short interval of time, and therefore this full phenomenon photoelectric effect is an instantaneous process. This process is an instantaneous process, that is no time lag between incidence of electron and ejection of photon, ejection of electrons. Incident of photons, incidence of radiation and ejection of electrons, there is no time lag between these, and therefore this photoelectric effect is an instantaneous process. And if the incident light is cut off, then photoelectric emission cannot take place. This is the second characteristic feature of the photoelectric effect explained by the Einstein. Now we have to see the third characteristic of the photoelectric effect, or the third observation of the photoelectric effect. Here we can say that more intense beam contains more number of photons. जेवढी इन्सिडेंट लाईटची, इन्सिडेंट रेडिएशनची इंटेन्सिटी जास्त असेल तेवढे नंबर ऑफ फोटॉन्सची संख्या सुद्धा जास्त असते. नाउ हियर इफ द फ्रिक्वेन्सी ऑफ इन्सिडेंट रेडिएशन इज ग्रेटर दॅन द थ्रेशोल्ड फ्रिक्वेन्सी अँड इफ इट कंटेन्स मोर इंटेन्स बीम, देन देर इज मोर कोलिजन बिटवीन फोटॉन्स अँड इलेक्ट्रॉन्स, आणि त्यामुळं इलेक्ट्रॉन्स आणि फोटॉन्स मध्ये जास्त कोलिजन घडून येतील. अँड इफ द एनर्जी रिसिव्ड बाय द इलेक्ट्रॉन इज ग्रेटर which required to knock, to emit from the metal surface, then large number of electrons are emitted. जेवढी इंटेन्सिटी ऑफ इन्सिडेंट रेडिएशन जास्त राहील तेवढं इलेक्ट्रॉन, मेटल मधले इलेक्ट्रॉन्स आणि फोटॉन्स या दोघांमधलं कोलिजन जास्त राहील, आणि जेवढं जास्त कोलिजन राहील तेवढे जास्त इलेक्ट्रॉन्स या ठिकाणी नॉकआउट होतील, या ठिकाणी एमिट केल्या जातील. अँड हेन्स the photoelectric emission is also larger, the rate of emission of electron is also larger, and large amount of photoelectric current will be flows through the circuit. Now we have to see the fourth characteristic of the photoelectric effect. आपल्याला माहित आहे when light is incident on the emitter plate, the electrons are ejected from the metal. if the potential given to this collector plate is higher, then the electrons are reached to the collector, and by increasing the collector potential, the electrons reaching to the collector will be increases and the photoelectric current will be goes on increasing. Photoelectric current हा या ठिकाणी वाढत जातो. But this photoelectric current will be depends the number of electrons emitted from the number of electrons emitted from the emitter plate will be depends upon the intensity of incident radiation. Incident radiation च्या intensity वर डिपेंड आहे. Number of photons containing radiation वर डिपेंड आहे. Even if we increases more and more, means this current will be increases to a certain limit. Certain limit पर्यंत हा करंट वाढत जातो. But later on, when all the electrons are knocked off, then even if the accelerating potential, या ठिकाणी accelerating potential आपण जरी वाढवलं तरी या ठिकाणी current will be remains constant, that is saturation current will be remains constant. म्हणजे ठिकाणी saturation current हा constant राहतो. This is the third characteristic, means the saturation current will be, or the photoelectric current flowing through the circuit, means initially when the accelerating potential is increased, then the current is also goes on increasing, but at a particular potential, after particular potential, even if the potential is increased, then the saturation current will be constant, or the current flowing through the photoelectric current flowing through the circuit will be remains constant, and that is called as saturation current. This is the fourth characteristic. Now we have to see the fifth characteristic. If we increase the intensity of incident radiation, म्हणजे आपण या ठिकाणी incident light ची intensity जर वाढवत गेलोत तर it is found that the value of saturation current is also goes on increasing. This is the fifth characteristic or fifth observation observed from the Einstein's experiment. म्हणजे आपण या ठिकाणी if we goes on increasing the intensity of incident radiation ची आपण intensity जर वाढवत गेलो तर saturation current also goes on increasing. या ठिकाणी आपण असं कन्सिडर केलं, this is intensity I1, this saturation current is for intensity I2, and this current will be for I3. When here I3 is greater than I2 is greater than I1, and hence the saturation current also goes on increasing. This is the fifth characteristic of the photoelectric effect. Now there are four characteristics are remaining. चार characteristics आपले राहिलेले आहेत आणि त्याच्यावरून आपल्याला त्या characteristics वरून आपल्याला आइन्स्टाईन्स फोटोइलेक्ट्रिक इक्वेशन आपल्याला ऑब्टेन करायचं आहे की जे आपण नेक्स्ट पिरियडला लर्न करणार आहोत. म्हणजे आपण या ठिकाणी 5 कॅरेक्टरिस्टिक्स पाहिलेत आइन्स्टाईन्स फोटोइलेक्ट्रिक इक्वेशनचे, किंवा आपण असं म्हणून आपण 5 ऑब्झर्वेशन्स स्टडी केले बाय युजिंग quantization energy or Einstein's postulate of the quantization energy or the we have to see the photoelectric equation in the next period.